We are on to the second lecture of the lecture series entitled Bracket Algebra. At the outset, let me mention the essential points or the takeaway from the first lecture. We introduced two notations proposed by Dirac, namely bra and ket. Ket is a column matrix or column vector consisting in general of n rows and one column. We can write ket A as 2 cross 1 column matrix A1, A2 in 2D or 3 cross 1 column matrix A1, A2, A3 in 3D or n cross 1 column matrix A1 to AN in ND. Bra is a row matrix or row vector consisting in general of one row and n columns. We can write bra P as 1 cross 2 row matrix P1, P2 in 2D or 1 cross 3 row matrix P1, P2, P3 in 3D or 1 cross n row matrix P1 to Pn in ND. We can add two similar kets so that ket A plus ket B gives a new ket C, and we can add two similar bras so that bra P plus bra Q gives a new bra R. We can multiply a ket with a number complex in general so that alpha into ket A generates a new ket D and beta into bra R generates a new bra L. Let us move on by introducing what we mean by the operation of Hermitian conjugation, also called adjoint operation or dagger operation, and is represented by dagger symbol or the cross symbol. To accomplish or execute this Hermitian conjugation operation, we need to perform two operations. They are, number one, taking complex conjugation denoted by star symbol, which involves replacing the imaginary unit I by minus I, and number two, taking transpose denoted by the symbol T, which involves replacing rows by columns and columns by rows. Let us consider a 2 by 2 square matrix, call it A hat or A cap. We note that we can perform various operations like addition, multiplication, etc. with the help of matrices. In physics, square matrices are looked upon as operators. Put in another way, operators are represented by square matrices. That is, the explicit form of operators is a square matrix. And operators are written by putting a cap or hat symbol atop them. So we write A cap to denote that A is an operator having a square matrix form. Let the explicit form of the operator A written as A hat be A, B, C, D. We take its complex conjugate denoted by star symbol that gives A star, B star, C star, D star. Now take transpose of A hat star denoted by T symbol that interchanges the rows and columns to give A star, C star, B star, D star. And this is the Hermitian conjugate of A hat denoted by A hat dagger. We note that had we taken the transpose of A hat first, we would have got A, C, B, D, and taking complex conjugate after that denoted by the star symbol would have given us A star, C star, B star, D star, that is the same A hat dagger. This means A hat star transpose equal to A hat transpose star equal to A hat dagger. Doesn't matter which of transpose or complex conjugate you take first, the same end result is obtained. So, A hat dagger is the Hermitian conjugate of A hat. Let me repeat once again that here hat stands for operator denoted by a matrix and dagger symbol stands for Hermitian conjugation. Let us now find the Hermitian conjugation of a column matrix. Consider the column matrix denoted by ket psi, the explicit form of which is AB. Taking Hermitian conjugate means taking dagger, and so let us consider ket psi dagger, which is column matrix AB dagger. Dagger is star transpose, so we get column matrix A star B star transpose. Transpose converts it to a row matrix A star B star, and this row matrix is identified as bra psi. So ket dagger is bra, ket psi dagger is bra psi, column matrix AB dagger is row matrix A star B star. Let us now find the Hermitian conjugation of a row matrix. Consider a row matrix denoted by bra phi, the explicit form of which is PQ. Taking Hermitian conjugate means taking dagger, and so let us consider bra phi dagger, which is row matrix PQ dagger. Dagger is star transpose, so we get row matrix P star Q star transpose. Transpose converts it to a column matrix P star Q star, and this column matrix is identified as ket phi. So bra dagger is ket, bra phi dagger is ket phi, row matrix PQ dagger is column matrix P star Q star. We thus have shown that bra and ket are Hermitian conjugates of each other. That is, bra is the dagger of ket and ket is the dagger of bra. So we can find or generate one from the other, bra from a ket and ket from a bra. Let us furnish some examples. Let ket psi be the column matrix 1i. What will be bra psi? Bra psi is the dagger of ket psi, that is dagger of the column matrix 1i, that is star transpose of the column matrix 1i. Take complex conjugate to get 1 minus I transpose, and then take transpose to get the row matrix 1 minus I. In the next problem, we start from a bra. Let bra psi be the row matrix 1i. What will be ket psi? Ket psi is the dagger of bra psi, that is dagger of the row matrix 1i, that is star transpose of the row matrix 1i. Take complex conjugate to get 1 minus I transpose, and then take transpose to get the column matrix 1 minus I. We can thus state that to each ket we can associate a bra by taking Hermitian conjugate. Let ket A be the 3 into 1 column matrix A1, A2, A3. Then bra A will be ket A dagger, that is dagger of the column matrix A1, A2, A3, or star transpose of A1, A2, A3. Taking complex conjugate gives A1 star, A2 star, A3 star transpose, and taking transpose we get the row matrix A1 star, A2 star, A3 star. Another example. Start with ket A equal to the column matrix 1, 0, 0, then bra A is the row matrix 1, 0, 0. Another example. If ket psi is the column matrix I1, then bra psi is the row matrix minus I1. We can also state that to each bra we can associate a ket by taking Hermitian conjugate. Let bra A be the 1 cross 3 row matrix A1, A2, A3. Then ket A will be bra A dagger, that is dagger of the row matrix A1, A2, A3, or star transpose of A1, A2, A3. Taking complex conjugate gives A1 star, A2 star, A3 star transpose, and taking transpose we get the column matrix A1 star, A2 star, A3 star. Another example. start with bra A equal to the row matrix 1 0 0, then ket A is the column matrix 1 0 0. Another example, if bra psi is the row matrix minus I1, then ket psi is the column matrix I1. We thus have shown that Hermitian conjugation or dagger operation means moving from ket to bra or moving from bra to ket, because ket dagger is bra and bra dagger is ket. We will finish off after addressing two more problems. If ket psi is C into ket phi, then let us find bra psi. C is a complex number in general. Now bra psi is ket psi dagger, that is dagger of C ket phi. This gives C dagger ket phi dagger, that is C star transpose bra phi, that is C star bra phi. We note that taking transpose of a number is itself, since we can think that a number is sitting in a 1 cross 1 matrix. So row and column refer to the same cell, and hence interchange of row and column has no effect. So taking transpose of C star is C star itself. Another problem, if bra psi is C bra phi, then let us find ket psi. C is a complex number in general. Now ket psi is bra psi dagger, that is dagger of C bra phi. This gives C dagger bra phi dagger, that is C star transpose ket phi, that is C star ket phi. Let us end up asking the question, can we multiply a bra with a ket? We shall discuss this in the next class.